Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize the various ways that a function can be represented, how to find function values of functions, how to use function notation to find points on a graph, how to manipulate the context of a problem and find solutions to fit another context, how to apply functions and their various representations to real-world applications, to examine functions and compare their function values and behaviors in given intervals, to recognize the characteristics of periodic functions and recognize them as repetitive intervals, to perform mathematical operations on functions to determine their function values, to perform algebraic operations on functions to determine their function values, to use sign charts to determine the positivity and negativity of functions, to find the products and quotients of functions, to find the function values when performing a composition of functions, and to recognize patterns in geometric figures as being functions. How are we learning it? Through the Reasoning with Representations of Functions Review Part 2 notes and the Reasoning with Representations of Functions Review Part 2 assignment. When can we use this information? To practice examining problems from all angles and examine the best ways to solve the problem, to find solutions to any kind of math problem, to examine how previous experiences and previous solutions can help lead to positive outcomes for current issues, to recognize repeated patterns in daily tasks and their common solutions, to plan for changes in rates of your electricity bill, to anticipate how your bill will change once a new rate takes effect, and to examine financial statements for businesses to determine times of profit and times of debt. How do you know you learned it? By getting a score of 4 on the Reasoning with Representations of Functions Review Part 2 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Reasoning with Representations of Functions Review Part 2 notes, and then I'll give you time to complete the Reasoning with Representations of Functions Review Part 2 assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on any incomplete assignments that you may have. Let's take a look now at the Reasoning with Representations of Functions Part 2 notes. The notes begin with the learning goals and success criteria. Now, what is a function? A function is a relation in which each element of the domain is paired with exactly one element of the range. So that means that for every x, there's exactly one y that matches with that x value. If there is more than one y to match up with an x, then it is not a function. So let's look at some examples here. So we have a bunch of dots here. We have tables, we have equations. We can see it in various different ways. But if we notice here, there's an x value here at x equals negative 4, and y is negative 3. There's no other y value that matches with it. Same thing with all of these. Here we have a straight line. I can pick any x value, and there's only one y that matches it. Here, again, same thing. Now, non-functions look something like this. So notice, if I pick an x value like x equals 0, so when x is 0, y is this one, it's this one, and it's this one. So there's 3 different y values that match up. That doesn't work. Same thing here. If we look here at this x value right here, there's 2 values there for y that make it true. So that doesn't work. Same thing here. If I pick x equals 0 here and here, there is 2 points. So again, not a function. Now, what is a function value? A function value is the resulting range value, so the y value, after a given domain value is selected that makes the function true. So in order to find a function value, we're going to plug in the given value for x. So whatever they tell us they want for x, the function value is the result or the output. So for instance, if I have f of 3 is equal to x minus 5. So all that means is I'm going to take 3 and plug it in, and then the result is what we call the function value. So we plug 3 in for x, and we get 3 minus 5, which is negative 2. So negative 2 is my function value. So finding a function value from a graph. So which of the following letters represents f of 4? So I'm going to go here to where x is 4, which is here. So notice I have f of 4 is represented by this dotted line p here. So it's right there. And we would say then that p represents f of 4. Now, if it asks for the actual solution, then that would be C. So P is our answer in this one. Now, if it actually gives us the value, so 2, f of 2. So here we would say f of 2, which is right here, and x is actually 2, so that means that we're going to select the actual point on the graph, which in this case is D. So if you see something like this in coordinate form, you're going to find the actual point on the graph. If you see it and it's just this part, like f of 2, it's going to be the value on the dotted line, which would have been B. Now, how do we find a function value from an actual equation? So it says, what is the function value for f of 6 for the function f of x is equal to 2x minus 5? So what we're going to do is we're going to take f of x equals 2 minus 5, and we're going to plug 6 in for x. So it goes here and here. So f of 6 is equal to 2 times 6 minus 5. Well, 2 times 6 is 12. 12 minus 5 is 7. So the function value for f of 6 is 7. Now, how do we perform operations on function values? So let's say, given the table above, what is f of 2 minus g of 1? So what that means is we're going to find what f of 2 is and then subtract g of 1 from it. So f of 2, if we look at f of 2, we can see that the value here is negative 2. So when x is 2, y is negative 2. So we keep that there. And then we look at g. So g of 1, which is here, when g is 1, the g of x is negative 1/2. So we take those two values, and then we're just going to subtract them, just like it says. So f of 2 minus g of 1 is the same thing as negative 2 minus negative 0.5, which is really plus positive 0.5. And we get negative 1.5 as our solution. Let's look at another example. So this one says, what is 4 times h of negative 2? So if we take h, so when h is negative 2, y is 4. So there's our value. And then we want 4 times that. So 4h of negative 2 is the same thing as 4 times 4. And 4 times 4 is 16. Now let's look at another example. So it says, what is f plus g of 2? Well, when we write that out, f plus g of 2 is the same thing as f of 2 plus g of 2. So when we do that, we find f of 2, which is negative 2, and g of 2, which is 1. And then we're just going to add those two together. So we add up negative 2 plus 1, which is negative 1. So when we do this and you see f plus g or f minus g or anything like that, really what that's saying is we're going to take f of this value and then whatever operation's there and then g of that number. So let's see another example of this. This time we have fg of 8. Well, fg just means multiplication, so really we can break that up and it becomes f of 8 times g of 8. So f of 8 in this case is 40. And g of 8 is right here, which is 4. So now we just multiply these together and we get 40 times 4, which is 160. Now, how do we actually do this with graphs? So they want us to sketch a graph of f plus g. So what we're going to do is we need to first figure out where these values go. So what is the domain of this, first of all? Well, the domain goes from negative 2 to positive 3. Now, notice this one goes to 4, and this one goes beyond that. So why is that? Well, it's the parts that are in common. Well, over here, there's no f value, so this is undefined at that part for f, so that makes the whole thing undefined when we add it together. So it ends right here at negative 2. Just like this one ends at 3, so we would say from negative 2 to 3 is where this exists. Then to create the graph, we need to find the sums of f of x and g of x and put those points on a sketch in a general area. So it doesn't have to be exact, but we should be kind of close. For instance, we could take this point right here. So when x is negative 2, f was 0 and g was negative 2. So if we add those two together, we get negative 2. So f plus g should be here at negative 2. If we look at a point like 0, well, at 0, f was at 1 and g was at negative 2. So 1 plus negative 2 is negative 1, so it should be here. So we just kind of plot those points as we go and figure out what the graph looks like. Now, what is a sign chart? A sign chart is used to determine on which intervals a polynomial function is positive or negative. So we talked about positive and negative intervals. Now we're going to use a graphical display to show where it's positive and where it's negative and when it changes between them. So the top of the sign chart represents the positivity of the function. So is it positive or negative? So we have positive, 0, negative, 0, positive. So that means it goes from positive to positive, and these are my x-intercepts. The middle of the sign chart represents the change in positivity, so it's just this little graph look here. It almost looks like a number line. And then we're going to put lines here to represent the x-intercepts. And the bottom represents the values. So where did these occur? So maybe I have an x-intercept at 1 and 3. So it was positive until it hit 1. Then it crossed and went negative. And then it crossed again here at 3 and then went back positive. So that's what this sign chart is telling me. So how do I create a sign chart from the information that I have on this? Well, I know that it's going to change 3 times. So it has an x-intercept here, and then an asymptote here that's going to change things, and then another x-intercept. So I'm going to go ahead and put these values in. So at negative 4, negative 2, and negative 1, that's where things change. So I was negative to start. So that negative goes here. Then it turned positive. So I put a positive here. Then on the other side of negative 2, I started negative and then turned positive. So it goes just like this. So this would be the sign chart that represents this. Now, multiplying functions. So it says that we're using f of g is equal to 2x plus 3 times 2x minus 2. So we should notice that there's 2 zeros here, right? So there's a number here that we can plug in for x that'll make this 0. And there's one here we can plug in and make it 0. So we should have 2 zeros. And then we're going to try sketching the graph of the function to determine the sign chart to use. We can always use Desmos to check our work. Now, dividing is no different, but now we know we're going to have an asymptote here. So wherever this becomes 0, whatever we need to plug in for x to make this 0, that's going to create an asymptote. So we should have an asymptote there. And then we can try sketching the function and determine the sign chart. We can use Desmos to check our work for this as well. Now there's a video here that shows you how to use Desmos to create a sign chart. So you can go ahead and watch that video now. Let's take a look now at how to create a sign chart using Desmos. So we're given a graph here and we're told where it crosses and we need to create a sign chart. So first of all, we need to break this up and show where the roots are, where it changes and goes from positive to negative. So I can see that that's at 1 and 3. So I'm just going to go ahead and draw a line here and a line here. And I'm going to call this 1 and this 3. So all I did was write on it by clicking and holding it down and drawing my stuff in. So now I have 1 and 3. I know that at 1, I'm even. I'm not positive or negative. So I'm neither positive nor negative, so I'll put a 0 there. Now, on the left side of 1, I am positive. I'm positive all the way up until I hit 1, so I'm going to put a plus sign here. Then between 1 and 3, I'm below the x-axis, so I'm going to call that negative. So this is negative, minus sign. And then on the right side of 3, I go back to being positive, so I put a plus sign. So this is how you can create a sign chart using Desmos. Now, how do we solve composite functions? So if we're given something like this is f and this is g, and I want to know what is f of g of 0. Well, what that really means is I'm going to solve for g of 0. So whatever's in the innermost parentheses, that's what I do first. So when I do that, I find g of 0, which is 0. So it's right there. Then we take that value and plug it in for f. So f of 0 is negative 3. So f of g of 0 is equal to negative 3. Let's look at another example. What is f of g of 0? So it means the exact same thing as the other one we just did. So in this case, we take g of 0, because that's the last one. So we always do it last to first. So g here of 0 is 0. And then we plug that in to f. So f of 0 is negative 3. So f of g of 0 is negative 3. Now, let's say we had f of g of 2. So we would find g of 2 first. So g of 2, which is right here, which is at 4. So we're going to go find when f of 4, which is there. So when f of 4 is 2, so f of g of 2 would be 2. Now let's take a look at an example here. So we have a pattern here where each time it's increasing. So we started with this shape here, and then we added basically a row here, and then we added another row. And so each time we're adding a row of these. So each time we add a row, we're really adding 3 blocks. So what patterns can we recognize about the figure? Well, in figure 1, there's 5 squares here. In figure 2, if we count them, there's 8. And in figure 3, there are 11 squares. So using what we know from our figures, is there a way to determine how many squares will be in any given number of figures? So let's say we want to know how many squares will be in figure 15 or 20. Is there a way to do that? Well, when we do this, you should be able to see that we have our original row here. So it's 3 times the number of rows, because we add a row each time. So 3 times n, number of rows. And then we have these 2 on the ends. So it would be plus 2. So in this case, our function could be 3n plus 2. Let's look at another example. On this one, we're given a tile, and each of them is broken up as well. So we have these patterns inside here. And notice there's a quarter piece here, a half piece here, and so on. So in figure 1, there's one half tile, meaning it cuts up into part of it. In figure 2, there's 1, 2, 3, 4, 5 half tiles. And then in figure 3, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 half tiles. So the question is, can we write an equation to figure out the pattern for this one? So what we should notice is from figure 1 to figure 2, we added 4 tiles to our figures. And then here from 5 to 13, we added 8 tiles. So we can see that the pattern is it's going to be 4, 8, then 12, 16, and so on. So each time we're going to multiply 4 times whatever the previous figure was, which is n minus 1. So it'd be 4 times n minus 1 would be my pattern. Now on this one, you can see that we have some hexagons. So here in the first one, we have 1, 2, 3, 4, 5, 6 sides. Then when we add 1 to it, we now have 11 sides because this one is shared. Then we do it again, and we have 16 sides. So what's the pattern we recognize here? Well, each time we're adding by 1 less than our original sides. So we should be adding by 5 each time, right? Because 6 plus 5 is 11. 11 plus 5 is 16. So it's 5 times n minus 1 times however many we had before, plus the original 6. So we have 5 times n minus 1 plus 6 would be our equation. Let's take a look now at the reasoning with representations of functions review part 2 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. The first one says, which of the graphs below represents f plus g? Well, let's pick some point on f and g right here. So f is the red one, g is the blue one. So if we take this, we can see that f is 1, g is negative 2. So when we add those together, we get negative 1, which is this one. So this one passes through negative 1, and it's the only one who passes through negative 1. So it's got to be this one. And then we'll take a look at the next question. It says f minus g. Well, we can see that f is, again, 1, and g is negative 2. So if we subtract 1 minus negative 2, we get positive 3. So this one passes through positive 3. This one does not. This one doesn't. And this one doesn't. So it's got to be this one here. And then we'll continue to answer all of these questions until we get to the end of the assignment. Once you get to the end of the assignment, go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.